In this lecture, we're looking at the requirements for standard. We know that volumetric methods provide a quick, convenient, and accurate means of analysis if and only if the reacting solution concentration is known accurately, and the end point coincides with the equivalence point. For the first factor, it requires the use of primary standard that is determined by weight. The masses are measured up to plus and minus 0.0001 gram. That is 0.1 milligram accuracy. The primary standard must be a substance that is very pure and it is a stoichiometric compound. That is, the molar mass is known accurately. A primary standard solution is made by dissolving a non-mass of the primary standard solid in a non-volume of solution for molarity or non-mass of solvent for molarity. In this unit, we use molarity, that is the concentration expressed as number of moles of solute in 1 liter of solution. Remember, solution is the solute and the solvent. What characteristic a primary standard should have? First of all, it must be obtainable in high purity, bigger than 99.95%. It should remain unaltered in air during weighing. This means that it must not absorb water from the atmosphere. It must not react with water in the air. It must not react with oxygen in the air. It must not react with carbon dioxide in the air. And the standard should maintain its composition unchanged during storage. Very often that we keep chemical in the lab for a period of time. Even we keep the chemical in very tightly closed container. Over time, it absorbs some moisture from the atmosphere. So that must be removed before the compound is used. So we remove it by drying in the oven or to use vacuum. This requirement is not usually met by hydrated substances because hydrated substances has water incorporated in the crystal lattice of the substance. It is very hard to remove the excess water from absorption in the atmosphere and the water from the crystal lattice. So that's why most of the hydrated substances cannot be used as primary standards. For accurate weight, the primary standard should have large molar mass to minimize the weighing error. So in general, the primary standard should be weighed at least 0.2 gram. The primary standard should contain maximum of 0.02% impurity, and this impurity should be tested. The primary standard should be readily soluble in the solvent. It must react with the analyte or the test substance rapidly and stoichiometrically, meaning that we must know the mole ratio for the reaction for our calculation. Rapidly meaning that the reaction should be completed. And we also have to consider the cost of the primary standard. So overall, there are not many substances can be used as primary standard, particularly those with water of hydration, the hydrated compounds. This is the list of substances can be used as primary standards for acid-base reaction, for complex formation reaction, for precipitation reaction, for oxidation reaction. This is for your reference. You don't need to learn off by heart this list. Primary standard for strong acid, we use sodium carbonate or sodium tetraborate. You see that both have fairly high molar mass, and we know the chemical reaction for these two reactions. Now look at the cost of sodium carbonate. For the purity of 99.5%, it is about $145 per kilo. For the purity of 99.999%, it costs almost $90 for 5 grams. This purity is often referred to as 5 nines, 99999, 5 nines. Very high purity. For sodium tetraborate, for purity of 99%, it is just over $50 for 100 grams. For 99.998%, it would cost about $50 for 5 grams. So for the cost, it is better to use sodium tetraborate at 99.998% purity. To standardize a strong base, we often use potassium hydrogen phthalate or benzoic acid. Again, you see here the molar mass are quite high, and we know the chemical reaction for this can be expressed in the chemical equation given here. In the lab, we often need large amount of acid and base. So we can make a large amount of this solution and then standardize them with primary standard. These substances now become secondary standard solution that can be used for the work in the lab. It is important to note that standard solution of sodium hydroxide should not be kept for more than 2 weeks in glass container because of the reaction with glass to form sodium silicate. So in general, standard solution of NaOH should not be kept in glass container at all. And also hydroxide react with carbon dioxide in the air. So the concentration of sodium hydroxide and potassium hydroxide drops with time. Therefore, the stock solution should always be kept in tightly closed container and only open when needed. We got to try to minimize the time it has contact with air.